Hello everyone. In this video, I'm going to give a brief overview of the stages of a project lifecycle and the construction process. A project can be viewed as a living thing that experiences from birth to death. People go through 8 development stages, according to a psychologist called Erickson, which you may have reluctantly been required to learn about this in that required psychology elective in your high school or college years. Now, before moving on to the next stage, there is a kind of crisis in each stage that needs to be resolved in life. And as engineers, we may think this way of thinking is foolish because life will force us to move on to a stage whether we want to or not. Although all of us know someone who is an adult acts as someone who is in an earlier stage, like a child, for instance. But we must all acknowledge that life goes through different stages. And similar to how there are 7 stages to a project, each of which has activities that must be finished and hopefully without a problem before moving on to the next. Stage 1, or conception, is where birth occurs, while stage 7 in this particular diagram is the last stage, which is sometimes known as death, or in terms of another vocabulary, demolition. Problems occur when projects are attempted to be managed by avoiding a stage or substage in this process shown in front of you right now. And like life, we will go to the next stage automatically. But if something was missed or unresolved in the previous stage, there will be problems when you are moving on from one stage to the next. Now, besides stage 1 and stage 7, we do have stages sprinkled across in the middle. So, for example, we have stage 2, which is planning and design, stage 3, construction, stage 4, commissioning and turnover, stage 5, occupancy or use, as well as stage 6, which is renewal. And all of these steps are crucial for creating a successful project and are tried and true, being practiced for a lot of businesses within various industries. And these phases or steps in a project are very helpful in outlining the creation and upkeep of a project for your clients or for your businesses as well. So let's get started. As mentioned just previously, the first stage is conception. And the identification of a need or constraint is the heart of this first step. Now, a regulatory requirement or business requirement may have what is called the spark for the need of a given project. And most of the constraints that are going to be applied to these requirements are determined by external forces. So, for example, environmental, legal, safety, and other factors may influence the regulations. And a need for business could be the need to increase productivity, launch a new product, renovate spaces to draw in clients, or recruit and retain staff, among other things. Unless the project is related to infrastructure, engineers typically don't start projects at this stage. And instead, business people are involved in this particular first stage for planning purposes. Now, budget requests are also frequently made at this stage at the very last minute, which can cause issues for the engineers later in the project progression. Now, owners of utility companies are encouraged to proceed to what we call the stage 2A before beginning to project or request budget values, which of course we're going to talk about this in the next slide. So stage 2, we have design and planning. And in this stage, we have 4 subphases. And these subphases may be merged as necessary for minor projects. However, though, with mid-size and large projects, they are usually going to be having 4 separate subphases. And they're the scope and budget, schematic, design, and documents. So fundamental scope and budget assessment is the first subphase, which comes after the project's conception and is typically the first phase in which an engineer or architect is involved, and usually internal to the client and not outsourced if resources permit. The primary scope and primary goals are established at this stage, and the following decisions, for instance, are typically ones made in this subphase. So for example, the first one being the quantity to be produced, second being the general size of the facilities required, the third being identifying the main equipment needed, and fourth being the general strategy for finish and fit. Now, interviews with the impacted parties or stakeholders should be used to build the requirements as I just mentioned. And the general arrangements and scope comprises only around 2 to 5% of the design completion and are typically provided to define the previously discussed decisions. An estimate is then completed after the scope development. Around 2 to 40% or 20 to 40% error in accuracy is typically expected at this low level of detail, and estimates are typically based on benchmarks, which are based on recently completed similar projects, experience, and a few square foot extrapolations due to the lack of detail. And to account for scope, design, and estimating inaccuracies, as well as human error and hidden conditions, a generous contingency of 20 to 40% is therefore being used. Annual capital budgets are frequently given for the stage of project scope development. However, they would later cause issues. Cost-benefit analysis and other financial factors can be done once this estimate is finished. Then the second subphase is schematic design. Now, as part of the owner's company, outside architectural or engineering consultants would typically be brought in at this point to help. Now, although small projects, from my experience, are frequently completed entirely internally by the owners or the utility or energy company staff if available. However, some larger and more advanced owners have the means to do this internally even for major or big projects. Now in this subphase, it builds on the previous one while providing the additional information needed to generate a more accurate budget. This is frequently the best level or phase for creating annual capital budgets. And depending on the complexity of the project, the design documents normally required at this stage reflect 5 to 25% design completion and often contains the deliverables as shown in front of you right now. So it includes the overarching plan, a fundamental scope write-up, diagrams such as PIDs or piping and instrumentation diagrams if you're in the oil sector, or one or single line diagrams among others if you are in the electrical utility sector, for example. And the fourth component is a comprehensive scope narratives in a typical divisional format like CSI with more information on the materials and as well as the finishing. The fifth component is a description of the main infrastructure and the utility requirements, as well as the sixth part is a draft of any regulatory scoping documentation that is necessary for the project. Now, following the creation of the deliverables as I just mentioned, the cost estimate can be further refined and revised with an expected error range of now 15 to 30% depending on the complexity of the project. The estimate can now be created using the same resources as the previous stage, with the exception that assembly estimate approaches can also be used along with a smaller amount of unit takeoff and vendor pricing data. However, the following substage should be taken into account to ensure a more precise estimate before final funding request can be made and where we're going to move on to final design. And as before, a pause for a business decision should be made before moving forward. Now, the next phase may cost 1 to 4% of the total project cost and should not occur unless there is a business case for proceeding. Now, moving on to the third subphase, which is design development. At this moment, the design effort is still focused on expanding the scope to the point where an extremely precise estimate may be obtained, and this subphase is also known as preliminary engineering. Here, following conceptualization is where some smaller ideas move on to the next phase. Documents at this stage resemble final building drawings, but lack particular features and specifications. The typical design document outputs for this phase, which builds on and improves the previous subphase, which is schematics, are what is shown in front of you right now. So we have the overarching plan, a simple scope statement, diagrams such as PIDs, single line diagrams, etc., comprehensive scope narratives in a typical divisional format, a description of the primary utility and infrastructure requirements, outline specs, any relevant regulatory scoping documentation's final draft, plans and drawings for all disciplines that are nearly finished but lack particular information, standard general information, as well as equipment schedules. Now, depending on the complexity of the project, the aforementioned deliverables account for roughly 20 to 50% of the design effort and are subject to an estimate error of around plus or minus 10%. Major design decisions and calculations must be completed in order to reach this estimate's accuracy, and qualified individuals are required to carry out the estimate. Architectural and engineering firms are frequently great at defining the scope but terrible at estimating. On the other hand, construction companies frequently excel at cost estimation but struggle with scope assignment. Consequently, a reasonable strategy is to have each perform an estimate on their own before convening for a budget reconciliation discussion. The following step normally costs 6 to 14% of the project's total cost. So you should actually stop here for a while to confirm that you are proceeding with the right business decision before moving on further. Now, if there are limitations on meeting the scope within an assigned budget, you should finish any value engineering or designed to budget exercises to figure out how you could move around for these limitations. One note that you should actually take note of is that changes often will cost more money as time goes on, and valuable schedule time will also be lost as well. So if you have any changes, it is good to actually plan it and be ready, well thought out early on rather than in the later stages. And then we move on to the last substage of step 2 or stage 2, which is construction documents. Now, drawings are completed in this substage to enable the acquisition of permits and the receipt of bids. And the drawings are expanded upon, double-checked, and comprehensive specifications are prepared. A control estimate might be carried out for bigger projects to make sure that there hasn't been any scope creep and to improve the original estimates. Estimates that are around 90% complete should be having only an error of 5 to 10%. And at this point, projections include vendor estimates and comprehensive unit takeoffs are included as well. And that really concludes stage 2. So moving on to stage 3 construction, we again have subphases, and there are 3 in this stage. So first of all, we have constructability reviews, we have bidding and permitting, and then we have administration and construction. So now let us look at the first subphase, which is constructability reviews. Now overall, designs should be evaluated for constructability, taking into account factors including safety, cost, methods, and materials, as well as other construction-related limitations and potential for value engineering, which is meeting the needs of a user creatively while reducing cost at the same time. People with construction experience should attend these design review meetings and review drawings at various stages of review. And this might necessitate bringing in a contractor or consultant early, which is a construction management approach, which also known as the design build approach. Now, speaking of construction, I want to tell you that I teach several online courses pertaining to the utility and energy industry that will help you excel in your career. And one such course is Construction Estimating Quantity Takeoff Fundamentals. Construction Estimating Quantity Takeoff Fundamentals is a comprehensive video course where you can learn industry-specific knowledge about construction estimation. I've handcrafted this course to allow students to acquire core fundamental knowledge on how to master the art of quantity takeoff. If you are a professional who are interested to work as an estimator for construction projects or just got a job in the construction industry, you will find this course of great help to get the fundamental knowledge you need to kickstart your professional career. This course can benefit anyone who wanted to work in any industry that needs to do estimation. And this course can help you to get an advantage at work or getting a job, as it gives you core knowledge in construction estimation that you would not have otherwise obtained unless you have worked in the industry. And knowledge is a power. Furthermore, you will get a certificate of completion for finishing the course, which allows you to show to your current or prospective employer that you are motivated to succeed in this industry. If you are interested, I have included the link in the video description below, so be sure to check it out. So moving on to the second subphase, and this is bidding and permitting. And the process for soliciting bids and obtaining permits is what is the heart of this phase. Now, today's fast-track projects frequently involve simultaneous permitting and bidding, and it is advised to deal with any site, zoning, and public hearing issues as early as possible in the design process. The various trade permits, such as HVAC and electrical, etc., can typically be submitted after the successful subcontractors let individual subcontracts, even though many regions only require a general construction permit. Now, there are many different ways to outsource work in general, but the most official and most general way, or most popular way to do it, is through the use of bids, which mandates that a project be carefully scoped and designed before receiving bids from bidders. Now, it is actually a good thing to consider pre-qualifying bidders prior to bidding in order to reduce the likelihood of the lowest bid syndrome, which leads to unqualified successful bidders. And if time permits, it is recommended that this is the greatest strategy for subcontract because it takes use of market forces and should eventually keep the lowest cost while maintaining quality. The magic number that seems to work best for obtaining the lowest market rate appears to be having 3 bids. One will frequently be much more fiercely competitive than the other two. But one should take a precaution, is that if one bidder's offer is significantly less, carefully go over the scope with them, because a hostile environment later serves no one's interests. There are 2 strategies usually being used at this sub phase, and where one is negotiated and the other one being time and material focused. Now, with the first strategy, or negotiated, the work to be done is to be negotiated with a single contractor. Now, the drawback of this is that unless the job is almost identical to work that has already been bid, it may be impossible to guarantee that a fair market rate is being offered. For proprietary systems where exclusive sourcing is required and there is no alternative vendor option, negotiated bidding frequently takes place. Include in the initial bid guaranteed escalation rates tied to an economic indicator such as the consumer price index, etc., when you know a vendor will become proprietary after the first install to prevent being taken advantage of later. And additionally, request price book discounts, etc., and demand that the vendor submit 3 subcontractor supplier bids for future work should be required as a point of an open book policy. Now, the second strategy is the time and material strategy, and with this method, work is completed in accordance with previously agreed upon labor rates and material markups. While this makes it possible for work to start right away, the job must be continuously monitored and might be challenging overall. Purchase orders are issued to chosen suppliers and contractors and subcontractors when the bidding process is complete. Contracts are typically advised for complicated projects, pieces of equipment or systems, as well as when costs reach a certain level. It usually isn't worthwhile to require a formal contract for smaller purchases. And finally, moving on to the last subphase of stage 3, we have administration and construction. And in this subphase, the contractors deploy to begin the project's construction after permits are obtained and bidders are chosen. And in here, you need to make sure that there are temporary safeguards in place to protect surrounding places and unrelated employees. Temporary facilities like porta-johns and office trailers are frequently being deployed in these sites. Post signs for both deliveries and the owner staff are also being deployed as well. Issue clear contractor procedures and rules and train each employee individually is also important when you need to issue work for construction. And projects should hold regular construction meetings to discuss any updates and problems being arise. Payment requests are often made on a monthly basis and should include a retainage, which is around 10% till close to project completion, to cover any construction issues. Continue to involve the A&E in meetings during construction, which is administration and engineers. Additionally, the AE should support construction administration by certifying shop drawings and submittals, issue change bulletins, and as necessary, analyzing payment and change order requests from the contractor. Be wary of the contractor making substitutions, since the quality can suffer greatly. And finally, we have to start the overall work process. Equipment and systems must be put into operation at the start of commissioning or earlier, and perhaps this stage should be classified as the next in the next phase, which is the stage 4. And prior to energizing the system or performing a full startup, other regulation and adjustments must be made as well. Before fully operating the equipment and starting other aspects of commissioning, this could involve factory representative startup, calibration, and other considerations. And now we move on to stage 4, which is turnover and commissioning. And as the name implies, it has two substages, which is first commissioning and then turnover. Now, before an equipment, facility, or system is put into use, it must first be commissioned. When facilities, systems, and equipment are started up and turned over to end users, commissioning is the well-planned, documented, and managed engineering approach that results in a safe and functional environment that meets established design requirements and stakeholder expectations. Commissioning then reasonably ensures that the next step of verification for regulated industries, such as the utility industry, will be successful by confirming that what was specified was installed and it functions as intended, and that it was successfully turned over to the users. Regulated industries, such as the utility industry, may require an additional step before put into final use or selling or actually energizing the equipment. And this process is referred to as validation or qualification. Establishing written evidence that offers a high level of assurance that a particular procedure will consistently result in a product that meets its planned standards and quality attributes is what it's meant by validation. And you will actually often see big commissioning procedures being done with major equipment such as breakers and power transformers. Now, the next phase, turnover, must also be finished before the project may be officially commissioned. A successful project handover includes training, project closeout documentation, and commissioning documentation. So let me talk about training. Staff members won't be able to operate and maintain the facility, machinery, or system in a safe and effective manner unless they have received the necessary training. And before determining training needs, rational questions should be asked, such as what is shown in front of you right now, including which systems or equipment require training, who requires training, which training are they in need of, how is training to be documented, as well as what certifications must the trainer possess. Now, other things that you also need to consider is the documentation and the project closeout. A project is not finished until all related paperwork is finished and given to the right people. And this covers operations and maintenance manuals, as-built drawings and specifications, etc. The documentation must be complete and organized so that it can be easily found and kept. To make future renovations simple, think about using electronic documentations or drawings such as CAD files or PDF files. So now moving on from the 4th step, the last 3 steps are actually quite short, so I'm going to go over very briefly. Now, the 5th step is use. It is time to move in or start operating after the construction is finished and any commissioning regulatory issues have been resolved. And the project lifecycle, however, does not end here or enter a state of inactivity, because now it comes to upkeep and protection. A useful tool in managing this stage of the project lifecycle is to establish a computerized maintenance management system, or CMMS. And this makes it possible to monitor the assets and carry out regularly scheduled preventive maintenance. Some regulated business demand that key elements have documented maintenance. Then we have the sixth stage, which is renewal. Frequently, assets undergo renovations or their purposes evolve. When shifting uses, take care not to break any rules. Fire protection systems can become overworked, occupancy classes can be broken, and emergency escape through doors, transit routes, etc. can be impeded. For example, some of the transmission poles, for instance, does not support the multi-circuit because of its height due to the clearances of lines. Now, the problem is if you want to actually use multiple circuits within a pole, you need to carefully assess it whether or not it works or not. So in this case, you will actually need to probably redesign the pole or even like actually replace it to actually have it as a higher height pole with a proper clearance to subject to more than one circuit, etc. Then there is finally the seventh stage, which is demolition. When it's time to remove the asset or demolish the building, a project has reached its conclusion. Now think about environmental factors like hazardous waste and materials such as asbestos, contaminated soil, etc. At some point, other demands take precedence over the facility, the apparatus, or the system, even though we must work hard and diligently to implement and maintain a project. Everything eventually falls into the act of just taking this and demolish it, and this officially concludes the end of the project life cycle. And this concludes the video. So if you want to connect with me, please look at our Twitter, which is at EE Bootcamp, which has the latest news in the world of electrical engineering. And don't forget to subscribe to our YouTube channel to get the latest free training videos. As I mentioned before, I offered a lot of online courses in various parts of the online portals on the internet, including Udemy, where I have courses based on utility industry, the energy industry, and renewable energy industry. So if you're interested, be sure to check those courses out. And I hope for the best of your career, and I'll see you in the next video. Bye for now.